Hello, 8th graders. We are going to move on to Chapter 4.2a, Simplifying Fractions and Writing Decimals. First of all, there are some definitions that we have to understand. One of them is a definition for a rational number. We will be getting a whole lesson on this about rational numbers and irrational numbers later. Right now, what you need to know is that a rational number can be written as a fraction, a over b, where a is an integer and b is any non-zero integer. You cannot have 0 in the denominator. If you remember back to our slope lesson in 3.3, we said that's undefined. Now note it's an integer, therefore it can be a negative number. Secondly, they can be expressed, rational numbers can be expressed as a fraction, a decimal, or just a plain integer. So for example, -4 is a rational number, so is +6, so is 1/2, so is -0.15. Another term that we covered in 4.1b is relatively prime. This is when two integers have only a common factor of 1. Their GCF is 1. And what we're going to do is simplify to what we call the simplest form fraction. Some people call it lowest terms. And you'll know when a fraction is in its simplest form or lowest terms when the numerator and the denominator are relatively prime. In other words, you can no longer divide by any other number than 1. There are a couple of different ways to go about reducing a fraction. One of the ways is to actually simplify by dividing the numerator and the denominator by the GCF. Now, some people can kind of do this instinctively. They can look at the numbers and go, okay, I get what the factor is. Some people might have to actually go through a little factor tree. I usually tell students, think about factors of 36. If you're going back to basic math facts, 36, the one that we probably all learned was either 4 times 9 or we learned 6 times 6. So then I take a look at my 40. 40 is divisible by 4. It's 4 times 10. So I'm going to use the 4. That will turn out to be my GCF. And I will get 9/10. Now, normally we do this mentally. Notice in B, we are getting a negative. And I should point out that the negative can be with the numerator, the negative can be with the denominator, or the negative sign can be even with the fraction bar. Most people probably bring it up to the numerator and put it there. So when I look at 12 and 20, I'm thinking that 12 is 4 times 3 and 20 is 4 times 5. So my GCF has to be 4. Or you can think about 2 times 2 times 3, and 20 is 2 times 2 times 5. But it's a lot faster and easier if you go back to your basic math facts. So this is going to be -3/5. Now again, it would be just as reasonable to put the negative sign even with the fraction bar, or have it in the denominator. Most of the time, like I said, we have a tendency to bring it up to the numerator. Most people will probably just use successive division, and this is the one that most people feel very comfortable doing. Some of you, you're going to look at this right away and you're going to know what to divide by. Others of you are going to go back to the divisibility rules and say, okay, I can get 3 out of both numbers. So I'm going to have 9/24. Now I go to my divisibility rules again. I can get a 3 out of each of those numbers, 3/8. 3 and 8 are relatively prime. And yes, I get it. Some of you are going to see it right away and say, well, Miss Scouten, 27 is 3 times 9, 72 is 9 times 8. Good. You're seeing the greatest common factor. That's fine. This method simply exists for people who have a harder time. It's one place for them to start if they can't think of the greatest common factor. For example, with B, a lot of people get shook. Oh, 98 is such a big number. Don't forget your negative sign, by the way. Other people, at least look at this and say, hey, I've got an even number. I can divide by 2. So I'm going to get 7 over negative 49. Now, hopefully at this point, you say, oh, I get it. 49 is 7 times 7. So I'm going to divide by 7, and I will get 1 over negative 7. Now again, some of you are going to go right away and say, I get it, Miss Scouten, 14 is the greatest common factor. It's going to be a 1 and a 7. Good, but if you can't see that, this gives you another way to attack the problem. How about fractions as decimals? Well, this is the part that most people don't like that much of. Sorry, it's the way it goes. Rational numbers can be terminating decimals. They have a definite end, such as 0.5, 0.25, 0.625, etc. Sometimes they are repeating decimals. Either the same digit or a group of digits is going to repeat. Probably the most famous one is 0.3 repeating. However, you could also have 0.8 with just the 3 repeating. And sometimes, in all honesty, you can have a whole pattern where it goes 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. How do we find them? By everybody's favorite function, division. We are going to put the numerator under a division bracket, the denominator outside the bracket. The bottom number, that denominator, goes outside. The bottom number is 8. It goes outside the bracket. The 5 goes inside the bracket. You're going to add a decimal point behind the 5, and you're going to bring it straight up and put it in the quotient. Then you might as well start adding some zeros. Most of the time, sometimes 1 will do, sometimes you need 2, sometimes you'll need more. Okay, 8 into 50 is going to go 6 times. We will get 48 when we subtract. And then we bring down the 0. We get a 2. We bring down the 0. 8 goes into 20. 2 times. 2 times 8 is 16. We get a remainder of 4. I'm not finished. I don't see a repeat. So I'm going to add another 0 and bring it down. Now 8 into 40 is going to go 5 times. 5 times 8 is 40. So 5 eighths is 0.625. What if I have negative 5/3? My best advice is bring that negative sign right there and then go do your division. Take the negative sign over right away and then don't worry about it. 3 to the outside, 5 under the bracket. 3 goes into 5 once. When I subtract, I get 2. I bring down my first 0. 3 into 20 is going to go 6 times. 6 times 3 is 18. When I subtract, I get 2. I bring down the 0. Right there, you've got the same number. So this is going to be another 6. Sure enough, you're going to get 18. You're going to get another 2. You're pretty well finished. 1.6, and the bar goes over the 6. This is what we call bar notation. 1.6 repeating. Negative 1.6 repeating. You try, you hit pause, and you do C. And then I'll show you how it looks. The 6 is going to go outside. The 5 is going to go under the bracket. Now you can probably guess that this will probably a repeat because 3 was a repeat in example 2 and 6 is a multiple of 3. So a lot of our 6's do repeat. 6 does not go into 5, but it will go into 50 8 times. That's 48. I subtract and get a 2. Then I have to bring down the 0. 6 into 20 goes 3 times. 3 times 6 is 18. Aha! When I subtract, what am I going to get? A 2. If I add another 0 and bring it down, looky looky, that means that 3 repeats. So 0.83, notice that my repeat bar only goes over the number that repeats. And that concludes lesson 4-2A. So, scouting out.